Good. Nate's gone. Good. All right, so we're looking at exponential functions. Yeah. All right. So complete the table of values for the years from 1916 and 1910. So every 10 years, the hump value doubles. So decades since 1960. So from 1916 to 1970, how many decades have passed? One. What's the value of the hump? The difference between values of consecutive decades. So from 20,000 minus 10,000 is a difference of 10,000. And the ratio of consecutive decades, so we have 20,000 over 10,000. And this reduces to what? A ratio of 20,000 over 10,000? 2 to 1. All right, so from 1980, how many decades have passed since 1960? 2. So now from 1970 to 1980, we've had another decade pass. So what happens to our home value? It doubles to 40,000.
Could you come to the main office, please? Thank you.
And then what happens between our difference in values? So what's 40,000 minus 20,000? And then the ratio of consecutive values. So we have 40,000 and 20,000. And this ratio reduces to what? Which reduces to 2. Alright, so do we feel comfortable to fill in the rest of this table? Alright, so let's take 1 minute to do that. And then for 2,000? Oh, 4. 8,000. 160,000 over 80,000. 2. 5. 32,000. 160,000. 32,000 over 160,000. 2. What patterns do you notice in the table? What else do we notice? Is the amount that's being doubled, is that the same? Or like the amount that's being added? Like, when we're looking at the difference, what's happening to the amount? This is changing, right? So if we have 10,000 and then 20,000, 40,000, 80,000. So it's the previous amount times 2. So even though it's doubling, that's not, is it a linear? Because it's going to create a straight line if we were to graph it. All right, so no, we'll look at that here in just a second. So write the house values as a sequence, identify the sequence as a arithmetic or geometric, and justify your answer. So looking at your table, is this, how would you classify this? Is this an arithmetic sequence or is it a geometric sequence? So with the geometric sequence, what are we doing? We're multiplying. And in this case, what are we multiplying by? 2. And so if we were to write this as an arithmetic sequence, we need to know our starting value, right? So how much are we starting with? We're starting with 10,000. What's our R value? What's our R value? 2, because we're doubling it each time. So in this case, what's our N value? Right, it's years, but it's in decades, right? So it's years by decades. So for this, if we know how many decades, then we can figure out what the home value is for 70 decades together. Questions? All right, so we identified this as a geometric sequence, and we wrote it again here. So we have questions here. All right, so now using the data from the table, graph the ordered pairs, decades since 1960, house value on the coordinate grid below. So we have decades. So at 0 decades, what was the home value? 10. The white is on the side is orange. That was red. That was green. So now after 1 decade, what was the home value worth? After 3 decades? After 4 decades was 160, correct? And then 5 was 3. Okay, so looking at this, is this linear? No. No. Okay, so the data comparing the number of decades since 1960 and the value of the house are not linear. Explain why using the table. Explain why using the table and the graph. So if it's linear, it's increasing the same amount each time, right? Is this increasing the same amount each time? No, it's doubling. So the longer that these people own the house, what's going to happen, or the longer the house exists, what's going to happen to that its value? It's going to keep doubling, right? So if in 2010 it was valued at $320,000, in 2020, what would the value be worth? 640, right? And then by 2030, it's going to be over $1 billion, right? So yeah. Oh wow. All right, so make use of structure using the information that you have regarding the house value. Predict the value of the house in the year 2020. Explain how you made the prediction. So what did we predict the house to be worth in 2020? So right now in 2010, it was valued at 320,000. So 10 years later, what's the value? 640,000. right, Tony would like to know what the home would be. The value of the house was in 2005. Using the same data, predict the house value in 2005. So 2005, that's not a full decade, right? It's half. So how many decades since 1960 is 2005? Right. So in 2000 it was 4 decades, right? And then we're going half a decade. So 4.5. So let's use our equation here. So in for n, because n is the number of decades, what are we going to put in for n? 4.5. So we have our starting value of $10,000. Our R value, it's doubling each decade, right? So our R value is 2. And we want to know what's the value in 4.5 decades. All right, so what is starting order of operations exponents? So 4.5 minus 1 is 3.5. My calculator's holding the USB port. All right, so 2 to the 3.5 power is how much? 7. 2 to the 3.5 power? 11.31. What's 11.31 times 10,000? Well, our answer, if in 2010 it was 320, it's going to be between 160 and 300. Oh, you know what? We started at 0, right? So do we have to start? Do we have to do the 1 minus 1? No, because we started at 0. That's why. That's why. All right. So do it again. So you did it correctly. So let's correct our equation. We did not. We started at 0. So here it starts at 0, so we don't have to do that initial minus 1. Now, if they had started 1960 at 1, what would we have to do to our exponent? Subtract 1, right? But here, so it's a good thing they had us test this out so we could catch our mistake. So we don't have to subtract that 1, so now what is that? Corrected equation. So 2 to the 4.5, right? Times 10,000. 226. All right, that looks better. And so that makes sense. So this is a good example of why it's always important to does our answer make sense? Does it fit with the data that we have? So since we're starting at year 0, we take our exponent. So that 4.5 decades or 45 years since 1960, and the home value in 2005 was worth $226,274,017. All right. So questions with that? So the increase in house value for Chinese grandparents' house is an example of exponential growth. Exponential growth can be modeled using an exponential function. And so an exponential function, you notice it has this real similar to that geometric sequence where A is your starting value and B is the amount that you're increasing by. Important to note, B needs to be greater than 0, and and your b cannot be equal to 1, because if you're multiplying by 1, are you changing anything? No. Because 1 to any power is always 1, because 1 times itself is 1. And your a value is never equal to 0, because 0 times any number is 0. Alright, so looking at number 11, so the value of Tony's grandparents' house is growing exponentially because it is multiplied by a constant factor for each decade. What is the constant factor? 2, right? Each decade, the home value is doubling. Alright, so a function that can be used to model the house, we have h of t equals 10,000 times 2 to the t. So we're going to use this for 12 to 17. And I think this is going to be your homework. All right, so I'm going to give you this time to get started.